Hello and welcome to this short video about vectors. And what we're going to be dealing with today is midpoints, and it doesn't always have to be exactly in the middle where we're calling it a midpoint, and parallel vectors. So if we have this first example, I've drawn out my vector triangle ABC, and it's telling me that P is the midpoint of C. Now if I wanted to find the vector BC, I would do minus x plus y. Go along here, minus x, and along there, plus y. So if I then wanted BP, because it's the midpoint, it's exactly halfway along, it's going to be a half of minus x plus y, which I can multiply out to get to get a half y minus a half x. If I then wanted something, say, A to P, what I'm going to do is go along to B and then to BP. So it's going to be x plus a half y minus a half x. Now we're able to use normal arithmetic here. X minus a half x is a half x plus a half y. Gets slightly more complicated, or looks slightly more complicated, if we're splitting a different ratio, if it's not split in half. Now what this is telling me is that if I had 11 parts, so I split my line into 11 parts, this part here is worth 8 of those 11, and this part here is worth 3 of those 11. Now I've got 11 from doing 8 plus 3. So let's just say that this vector here is 2x and this vector here is y. If I wanted to get from B to C, I'd be minus 2x plus y. So then to get from B to Q, I'm going to do 8/11ths of BC. And as I say, the reason it's 8/11ths is because of that ratio. So that's 8/11ths of minus 2x plus y, which is minus 16 over 11x plus 8 over 11y. And when we have parallel vectors, we have a common multiplier. So here, 3 times 4 is 12, and minus 2 times 4 is minus 8. So we can see that CD is equal to 4 lots of AB, so they are parallel. This is interesting here. FG is 5x plus y, and GH is 5/3 x plus 1/3 y. So we can see we have a common multiplier of 1/3. So they are parallel. But I also know they're on the same line, because G is in both vectors. So they're parallel and they're on the same line. Now to show that things are on the same line, you do need to have a shared letter between the two vectors that you're looking at. But if I had something like this, 3x plus y and minus 6x plus 2y, they're not parallel, because the multiplier there is minus 2 and the multiplier there is 2. So let's look at a couple of questions. I want to find A to B. Well, that's minus A plus B. Minus A plus B. That's telling me that P is a point on the line such that PB is in a ratio of 3 to 1. So if I split my line up into 4, that's worth 3 of it and that's worth 1 of it. So I want to find O to P. Now what I'm going to do is go O to A to start with, and then it's going to be 3/4 of A to B. And the reason that I've gone that way is so I already know what AB is. And so it's 3/4 of it, because this is splitting my line up into 4 parts, and that part of AP is worth 4 of it. So OA is just A. I'm adding 3/4 of minus A plus B. So that's A minus 3/4 of A plus 3/4 of B, which is 1/4 A plus 3/4 B. Okay, and here's another exam question, perhaps a little bit harder, but the first bit's just as easy. Find the vector PB in terms of A and B. So if I want to go from P to B, I'm going to go to A and then to B. So that's minus 3B plus A. And they've split that vector up for us to do watch out for things like that. Now it wants us to show that NMC is a straight line, and I'm going to use parallel vector rules to help me with that. Now, if we have a look, it tells me that B is the midpoint of AC, so that must also be vector A, because if it's a midpoint, that section and that section are the same. So I also know that AC is 2A. Now, if M is the midpoint of PB, PM is going to equal a half of PB. And we know that PB is minus 3B plus A, so PM is minus 3/2B plus a half A. So, to show that these are on a straight line, I'm going to need to know the vectors NM and MC. So, NM is going to be NP plus PM, which is B plus a half A minus 3/2B, which equals minus a half B plus a half A. Now for MC, I'm going to do MB plus BC. Now I know I haven't officially found out MB anywhere, but if M is the midpoint of PB, PM is going to be the same as MB. Now, PM is minus 3/2B plus a half A, so that's going to be the same for BC, and then plus another A, and that gives me minus 3/2B plus 3/2A. So these are the two vectors that I'm particularly looking at. Now we can see there is a common multiplier here. Minus a half B times 3 is minus 3/2B, and a half A times 3 is 3/2A. So therefore, NM and MC are parallel, and as M is part of both of those vectors, they are on the same line. I hope that helps. Thanks very much.